Assalamu alaikum wa rahmatullah. Today we are looking at question 7 of the prelim paper, the chemistry paper. And if you look at question 7, we read 7.1, determine the term acid according to the Arrhenius theory. Now again, we cannot underestimate our definitions. Definitions must not be underestimated. So let's work out our definitions. Question 7.1. So 7.1, the question is, what is Arrhenius acid? An acid is a substance. We get the Arrhenius acid and we get the Lowry Bronsted acid, right? And the Arrhenius acid is an acid is a substance that produces hydrogen ions, H plus ions, right? And Lowry Bronsted theory says an acid is a proton donor. But we're not going there. We're looking at an Arrhenius acid. That's the question. 7.2. So 7.2, the question is, from reactions X and Y, identify the reaction that illustrates the Arrhenius theory. If you're looking at X and Y, HF gives you plus H2 gives you H3O plus F minus, NH3 plus HNO3 plus NH3 gives you NH4 plus NO3 minus. So which produces the H plus ion? We see it will be reaction X. Write down a balance equation. Wait, let's go on. From reactions X and Y, identify the reaction that illustrates the Arrhenius theory. It will be X, 7.2.1, because the H produces H plus ions here. H2 becomes H3O plus. So it will be X. Seven point two point two. Write the balance equation for the hydrolysis of NH4 plus ions. So we take NH4 plus, we react it with water, what do we get? This is a reversible reaction, and then we see we can get NH3, but you also get, because if the hydrogen goes across, we get H3O plus. So we'll see a solution, we'll get ammonia, plus we'll get H3O plus, the oxonium ion. So there'll be more H3O plus in the reaction. Will the result of the solution in 7.2.2 be acidic, basic, or neutral? Give a reason for your answer. So what did we say? Because the ammonia will undergo hydrolysis, it will form H3O plus. So there's more H3O plus in the solution, so the solution will be acidic. Because the concentration of the H3O plus ions increases. Because there will be more H3O plus ions in solution. H3O plus. Okay, 7.2.3. That's how we could answer it. 7.3. A sodium hydroxide solution is prepared by dissolving 4 grams of sodium hydroxide in water to make a 500 cm cube solution. Calculate the concentration of sodium hydroxide solution. So concentration 7.3.1. 7.3.1. Concentration is equals to number of moles over volume. You can say number of mole actual mass over molar mass times volume. We're going to C is equals to N over V, depending on what we are given, right? So looking at our solution, we got actual mass of sodium hydroxide, which is 4 grams. Molar mass, we can work it out, and the volume is 500 centimeters cube, which we can work it out. So let's just use this first equation. We could use the other one as well. The NaOH. If you have to work out the molar mass of NaOH, it will be 23 plus 16 plus 1. It gives you 40 grams per mole, right? If you have to work out the molar mass, so then if you work it out, you can say concentration equals to actual mass, and I told you the actual mass that is formed is 4 grams. They told us it's 4 grams. It will be 4 grams. 4 grams. And actually your molar mass will be 40 grams per mole times your volume, which is 500 centimeters cube. You take 500 centimeters cube and you divide it by 1000, you get 0.5. Get 0.5. And if you work it out, 4 divided by 40 times 0.5, that's 0.2 mole per dm cube. Alright, so that's how we can work out basically the concentration of our sodium hydroxide solution. Then if we go further, the question says, during a titration, 12.5 cm cube of sodium hydroxide solution. Alright, so now we must work out what's given here. 12.5 cm cube. There's a volume of the base. Utilize 25 centimeters cube of the sulfuric acid solution. And we got a concentration of the base. So calculate the pH. So let's just see what we've got, right? We've got 12.5 centimeters cube of we got a volume of the base. So let's write this down. It's question 7.3.2. Let's just write it down. 7.3.2. We got volume of base. Do we have concentration of base? Do we have volume of acid? Do we have concentration of acid? Let's see what we've got. We've got the volume of the base, concentration of the base, volume of acid, concentration of the acid. We worked out the sodium hydroxide concentration in the earliest one was 0.2 mole per dm cube. Sodium hydroxide is a base, so the concentration of your base will be 0.2 mole per dm cube. And they told us the volume of the base 12.5 centimeters cube of sodium hydroxide, so 12.5. So you can write 12.5 here. And then going further, neutralize 25 centimeters cube of sulfuric acid solution. 25 centimeters cube of sulfuric acid solution. So that's your volume. And we won't know the concentration of the acid, right? So we know the equation that we usually work with. We're working with titration, CAVA all over CBVB is equals to NA over NB. Now, do we know the number of moles of acid that reacts with the base? We can see here there's 2 base, and then there's H2SO4 is 1 acid. So 2 base over 1 acid. 2 base over 1 acid. We should remember that. This will be 2 base over 1 acid. The concentration of the acid, we don't know. The volume of your acid will be 25. You don't have to convert it because it will cancel out. Concentration of the base is 0,2, and your volume of your base is 0,2. So taking it onto the other side, and if you work out the calculation, 1 times 0.2, this is not 0.2, volume of the base is 12,5. Let's just fix that up. Study errors will finish you up. Volume of base is 12,5. Alright, and if you work it out taking your calculator, say 12,5 times 0.2 divided by 2 times 25, and you get the concentration of your acid will be 0,05 mole per dm cube. So there's a concentration of our acid. Right. But when we work out the concentration of the acid, we see calculate the pH of the H2SO4 solution. So pH, we know that pH is equals to minus the logarithm of your H3O plus ion, right? Or your H plus ion, whichever way you want to say it, H3O plus ion. But now, if you got 0,05, if you got 0,05 mole per dm cube H2SO4, what happens when it breaks up? We get 2 H3O plus that are forming because it's a diprotic acid. Therefore, we can say 0,05 multiplied by 2 will be the number of 0,05 multiplied by 2 will give you the number of moles of acid. So if you work out your pH is equals to minus log the 0,05 times 2 or times 2 will be 0,1, and if you work that out, pH minus log of 0,1 will give us the pH of 1. So that will be the answer to 7.3.2. So yeah, so that is the answer to question 7, where we've worked out all our questions, worked out our pH, we used the titrations, we use mole ratio, we must learn our definitions, we must know the definitions of acids and base for the application. Shukran.